We continue our discussion of binary search trees. So far we've talked about how to add new nodes to a binary search tree. We've also considered how to find a node in a binary search tree. So the next thing we want to talk about here is we would like to talk about output of a binary search tree. This can be very interesting. There are several ways to do it. Output of a binary search tree. So why don't we consider a simple example first. So we've got our root up here. And we're pointing at a node here, Mary. Let's make it a small binary search tree. So over here is Al. And over here is Sue. Now, there are lots of ways to output a binary search tree, but one of them, the one that is going to be of big concern to us, is what is called the in-order traversal, or in-order output. In-order output. Or if you prefer, an in-order traversal. And what that means is that when I go ahead and output this structure, I'd like to see this. I'd like to see Al, followed by Mary, followed by Sue. Okay? That it just comes out in alphabetical order. Now, with just 3 nodes in it, this is not going to seem that difficult. But this is our friend recursion is going to come back here now. Isn't recursion your friend? And this is going to be an example of where recursion is actually going to help us, because it turns out that to output a binary search tree without recursion is a very time-consuming process, whereas if we use recursion, it's going to be fairly simple. And the idea is that basically whenever we're referencing a particular node, the idea is that we want to output the left subtree. Then we want to output this node. And then we want to output the right subtree. So if the idea here is that we are outputting a tree, okay, and that's given by this, you can see that this is going to be a recursive call. This is going to be a recursive call. This over here, just outputting a node, we're assuming that the node, we have a toString method written for it. And again, if we're not careful here, as we know with all recursion, you could get into some infinite loop. We have to decide when do we do this and when don't we do this. And we know that this is coming in with some node n here. So if we're outputting the tree, and again, you'll excuse the informality here, if we're coming in with some node n, we just want to say something to the following effect. If n doesn't equal null, then go ahead and do this. And it turns out, this is it. This is the whole idea for outputting a binary search tree in order. So let's see if we can do this. So let's imagine with this tree, and I am going to say public void, and I'm going to say in order node n. And I just come in here and I say the following. If n doesn't equal null, then what I want to do is I want to do in order of n.getLeft. And then what I want to do is a system.out.println. n, again assuming that we've written the appropriate toString method for this, and then I would do an in order of n.getRight. And that's the whole thing over there. So we can imagine that if I came in here and I did this with root, so that if I did in order of root, okay, well if I come in here, we note the following. If root doesn't equal null, well it doesn't, so the first thing I'm going to do is I'm going to do an in order of root.getLeft. Okay. Now, if we wanted to follow the recursion along here, maybe we're going to be able to do this in a very clever way. Okay, what this is going to do, let's see if I can do this. This is going to come over here. Okay, and now what I am going to do, let's see, we need to keep the tree, the picture of the tree there. Okay, I'm trying to be clever here. Let's get rid of this line here. Okay, but the point that we have to make, that we have to remember here now, is that this is now calling in order, and I'm going to write it this way. I'm going to write that we have a reference to Al. And it's going to come in here and it's going to say if the reference to Al doesn't equal null. Well, it doesn't. Okay, so what is it going to do? We're going to come in here and we're going to call in order of reference to Al dot get left. Okay. Now, we're going to make yet another call. So this is going to get a little bit messy, but I think you'll follow. Let me erase some lines here. Let me get rid of that. Now the first thing I want to note is that I am going to be doing a reference to al.getLeft. Notice that is a null pointer. So what's going to happen over here is now this is going to make another call to in order, but now this is going to be a null pointer. So we come in here and it goes if null doesn't equal null. Well, it does. So none of this gets executed. So I come down to here and this is all done. I'm finished with this one. So now what happens is I return over to here now, and this now says system.out.println, and this is the reference to Al. Well, what that's going to do is I'm going to come over here and have an output window that's going to output Al. And now what I'm going to do is I'm going to come over here and I'm going to do an in order to the reference to al.getRight. But recognize that I'll put it over here, that's just another in order of null. Okay, so it's not going to do anything, but it is going to come back over to here Now we've hit the closing brace over here. So now what happens is we're going to come back over here, and now we're going to the next line. Well, what's the next line here? Well, this is going to say system.out.println root. Well, that's going to output Mary. Okay. I feel like I'm okay. And then what I have to do over here is I'm going to do an in order of root.getRight. And you can see that that's going to go through the same thing over here with Sue. It's going to make a recursive call to Sue. It's going to make a recursive call to this null pointer. That's going to return to the recursive call for Sue, and it's going to output Sue. And then it would make the recursive call to the right side. Then that recursive call would end. Then it would come back to the recursive call for Mary, and that one would end. And here's where my output would be. It would look like that. Pretty clever. So let's try a few other tricks here, because there are other ways to do output. Let's consider a bigger tree. Suppose I had a tree that looked like this. Here's Mary. Here's Dave. Here's Al. Over here is Ed. Over here is Stan. Roger. Tom. Now, I'm going to write a different thing here. I'm going to have a public void. I'm going to call it pre-order. And what I'm going to do here is I'm going to say if n doesn't equal null, I'm going to flip the order around. Pre-order says I'm going to print out the node first. And then I'm going to do a pre-order of n.getLeft. And I'll do a pre-order of n.getRight. And I'll close that up. And I'll say, what happens if I do a pre-order of root? And the way that I'm going to figure that out is as follows. Let's move this over here. And if I do a pre-order of root, well, what's going to happen is, so here's root pointing over here. I'm going to print out Mary. And then what's going to happen is I'm going to be doing a pre-order on the left subtree. So I'm going to write it like this. Pre-order of, and I'll write it this way, a reference to Dave, Al, Ed. And then I'm going to do a pre-order of a reference to Stan, and then Roger, and then Tom. Okay, so that's what it's going to look like. This will get output right away, but now I'm getting stuck over here in this. Well, what this is going to do, well, it's going to output Dave. And then what's going to happen is it's going to do a pre-order on a reference to Al. And then it's going to do a pre-order on a reference to Ed. Okay, well, what's going to happen over here, got to take this a step further. Let's see, there's some blank paper. Okay, when I do this pre-order on Al, what's going to happen there? Well, it's going to come over here and it's going to output Al, and then it's going to do a pre-order on null, and a pre-order on null. Okay, and this is just going to return because there's nothing left to do. Okay, so now take a look at what's happened here. I've output Mary, I've output Dave, I've output Al. Okay, I'm going to come back over here and do this one on Ed. So that's going to output Ed, and then it's going to do a pre-order on a null, and another pre-order on a null. And these will just return, and these will just return. So if we're following the output, this is going to be output first. This would be output second. This would be output third. This would be output fourth, like that. And we can see that what's going to happen over here. We can see that Stan would be 5, Roger 6, Tom 7. So that if I were doing the pre-order traversal of this big tree, it would be Mary, and then it would be Dave, okay, and then it would be Al, and then it would be Ed, and then I would come over onto the other side, and it would be Stan, and then it would be Roger, and then it would be Tom. Okay, so this is a pre-order traversal. And yes, there is one more. Post order. And you can guess what this one is too. If n doesn't equal null, what do I want to do? I want to do a post order of the left side. And then I want to do a post order of the right side. And then I would do a system.out.println of the node. So, if I were to do a post order of this, I know that what I would be doing is I would be doing a post order. First it would be Dave, Al, Ed. It would be a post order of Stan, Roger, Tom, and finally at the end I would output Mary. That's not going to happen for a long time, is it? So I got to come over here and I've got to do this one. Well, this one is going to be a post order to Al, so I'll write it this way. And then there's going to be a post order to Ed, I'll write it that way. And then finally I would output Dave. Likewise over here I would be doing a post order to Roger. I would be doing a post order to Tom. Then I would output Stan. then I would output Mary. Well, if I come over here, if I'm going to do a post order of this, I'm ultimately just going to output Al. Then I'm going to output Ed. Then I'm going to output Dave. Then over here it would be Roger. I would finally do Tom. I would do Stan. And then I would do Mary. So this is post order. And those are the 3 different ways to do output of trees. Imagine what it would be like to do this if we didn't use recursion. It would be a mess.